Here we're going to be taking a look again at subsets and proper subsets. And now we're going to be talking about finding all of the subsets and proper subsets of a given set. So let's begin with example 6, part A. List all of the subsets of set D. So remember, subsets can be equal to the original set. So as you work through these, what I really encourage you to do is start with the smallest subset possible. That would be the empty set, the set that contains no elements. So set D is 6 and 8, but the empty set would not contain any elements. Then my next encouragement is write down all of the sets that would contain a single element. So in this case, you could have the set containing only the number 6 and the set containing only the number 8. And then once you've got all of the subsets that contain one element, go on to the subsets that contain 2 elements. And in this case, 2 elements is the most that we have. But if we had a larger set, then I would go on to list all of the subsets with 3 elements and then 4 elements, etc., in an effort not to miss any. Now for part B, list all of the proper subsets of set D. So remember, to be a proper subset, you cannot equal the original set. Okay, they cannot be equal. So the proper subsets would be the empty set, the set containing only the element 6, and the set containing only the element 8. You cannot include the entire set D in order to be a proper subset. Now, again, I'm going to ask you to pause the video, go through question C and question D, and then restart the video and see how you did. Okay, so following my pattern, again, listing the subsets of set B, I started with the set that contains no elements, the empty set. Then I listed every set that contained a single element, so just 4, just 6, just 8. Then I listed all of the sets that contain 2 elements. Please remember that order is not important. So the set 4, 6 is exactly the same as the set 6, 4. There is no difference. So if you listed both orders, you need to get rid of anything that is a duplicate. And then finally, I listed any set that had 3 elements, in this case, the entire set. Moving on to set D, which are the proper subsets of set B. Again, we cannot be equal. So the only set that I need to throw out is the entire set B containing 4, 6, and 8. All right, pause the video again. Now list all the subsets of set C. All right, so check it out. How did you do? Again, I've got the empty set, then my sets that contain a single element, 2 elements, 3 elements, and 4 elements. You should have a total of 16. And remember, order does not matter. So if you have any combination of those elements in your curly braces, you have the same set that I do. If you have duplicated because you've rearranged, again, you need to cross out any of those duplicates. And as for question F, which of the sets listed is not a proper subset of set C? Again, no equality allowed. All right, moving on to the next page and using the work that we just did, whenever you look at set D, which is what we looked at in part A and B of the previous question, there were 2 elements in the set. Whenever you count how many subsets there were 4, and there were 3 proper subsets. Again, this came from part A and this came from part B of the previous page. When it comes to set B, there were 3 elements in the set. There were 8 subsets. We found that out in part C. And there were 7 proper subsets, which we found out in part D. And then moving on to set C, there were 4 elements, which had 16 subsets from part E, 15 of which were proper subsets, which we found out in part F. So the question is, can we find a pattern? Now, I think the pattern going from the number of subsets to the number of proper subsets is pretty simple. We're obviously subtracting 1 to go from 4 to 3, 8 to 7, and 16 to 15. The question is, how do we use the number of elements in the set to come up with the number of subsets? It's not quite as simple as saying like 2 times 2 is 4 or 2 times 3 is 8. But what we are doing every time is we are multiplying by 2 as we work our way down. And so if there are any number of elements, notice that this is 2 to the second power. This is 2 to the third power. This next one is 2 to the fourth power. And the exponent there is how many elements are in the set. So regardless of how many elements there are, the number of subsets is 2 to that power, n in this case. And then to get from the number of subsets to proper subsets, we just subtract 1. Again, the one we're removing is that full set. We can't have equality. So to summarize, for any set with n elements, there are 2 to the n subsets and 2 to the n minus 1 proper subsets. So real quickly, just a few examples here. If set n is the numbers 1 through 10, how many subsets of set n are there? Well, the number of subsets is 2 to the n power. Here there are 10 elements in the set, so 2 to the 10th power is 1,024 subsets. Set M contains 5 different sets of mountains, so how many proper subsets are there? Well, proper subsets, again, we can't count equality, no equal sets, so 2 to the n minus 1. There are 5 elements in the set, and we subtract 1. 2 to the 5th is 32, minus 1 gives us 31 proper subsets. And then finally, if S is the number of states in the U.S., write an expression for the number of subsets and the number of proper subsets. So the number of subsets, again, is 2 to the n, and in this case there are 50 states, so that would be 2 to the 50th power. For proper subsets, it's 2 to the n minus 1. So again, 50 states, take away 1. And it just is an expression. Your calculator will go on like calculator overload. It won't want to calculate a number quite that large. So we'll just leave it as 2 to the 50th and 2 to the 50th minus 1.